Hi, everybody. My name is Lauren Smith. I'm a student at Moore Norman Technology Center, and recently, myself and five of my classmates, also in the programming class, participated in what's known as the NASA App Development Challenge. So, about a month ago, I gave a lightning talk giving a rundown of the challenge, and so today I want you all to see how it turned out. So, in case you missed my first talk, a little bit of the background as to what the challenge is and what we had to do is the NASA App Development Challenge is actually part of the Artemis mission for NASA. And the Artemis mission aims to land the first woman on the moon by 2024. And furthermore, is one of their next missions to the moon that they're planning, where they plan to land on the lunar South Pole. And that's where we get into the details of the challenge here. As you can see through this picture, which is found in the challenge guidebook, what we had to do is say, hypothetically, an astronaut lands at the landing site marked right there. And so we had to make a visualization of this landing site in the lunar South Pole and make it to where there could be a displayed path that could safely get the astronaut over to this desired location. So when it comes to the challenge, the first thing that we had to do here was develop the terrain itself. So here are some pictures of how the terrain ended up. So here's like a close-up picture, and here's a more aerial view of the terrain supposed to look like the craters of the moon in the lunar South Pole. So to do this, we used longitude, latitude, and slope coordinates, which were given to us by NASA in a large file. So we got all of that information for each individual point. So we made a program to read them in a certain number of lines at a time. And then furthermore, longitude and latitude were converted into measurable units. So that way we could plot them onto pieces of terrain and make sure that they were the appropriate size using a height map. So after developing the terrain, the second thing we had to do is apply color so we could display information such as the slope and the height of the land, because in order for a pathway to be considered safe for an astronaut, it had to be less than 15 degrees of slope. So these color maps were key for showing this direction. So you see here is a picture of a height map, and then this is a picture of the slope map and what that looks like in color. And then once again, here's a different view of that. So to develop the color map, what we ended up doing is we found a script online for Unity, which applies textures to terrain based on rules, which in this case were our height and our slope that we had for each individual texture. Then the textures were added and defined where they should appear based on the height or the slope. So then after making these rules on these textures, so the code knew what to do, we added those textures and rules on where they should appear on our terrain using a splat map, which stored each texture in use on a given point of the terrain and how much of each texture should appear. So basically, we took a multi-step approach where we determined where it should go on each texture and then put it into a splat map altogether, so the code knew what to apply to based on the given information from the splat map on those textures that we had already made. Now, after developing the terrain and the color map, now we had to make the path for the actual astronaut in order to follow to get to that location. Furthermore, the other thing we had to do along with following this path is we had to make what are called communication link checkpoints, which is where the Earth was in clear view from the lunar South Pole, meaning that the astronaut could easily communicate with Earth. So at the top here, you can see the path on its own, and then on the bottom here, you see the path, and along the path, there's a communication link checkpoint right over there at that little arrow. So in order to make this pathway, in order for the astronaut to follow and safely get to the desired location, we used a free package for Unity called A Pathfinding, which we created an object that would find the different paths for us that we could take based on the needing to be less than 15 degrees of slope rule. And then we created a path based on that path that the AI object we traversed. So the AI would create the path based on the rule, and then we would go back and highlight that path with the blue color that you saw. Furthermore, with the communication link checkpoints, we used an algorithm to take these points that could be communication link checkpoints based on certain variables, showing if the Earth was in view or not. And then we used an algorithm to calculate the further distances that we could use, as we want these communication link checkpoints to be as far apart as possible. Finally, the last thing we did here is there are different options for the user to use along the wayfinding path in order to have different optimizations, such as a shorter path, but it has a bit more hills, so it's a bit harder to get through, or a longer path, but it's easier to walk. So we have different pathways that we can create based on the button or option that the user selects. Now, finally, after that was all done, we had to create the user interface so that the user could interact with the project itself. So in order to do this, we developed each icon individually, like you see that sun standing for if we were using a flashlight or not in order to light the ground. So one mode shows off, the other on. And then we combined all of these icons at the top of the project, as you can see down below, into one user interface bar. So the really cool thing about our user interface is we made sure that within our color maps and our user interface, it was as colorblind friendly as we could make it. And furthermore, we opted to use icons as opposed to words. That way, anybody that speaks any language could easily use the project, and it could be as accessible as possible since we don't know who will be needing to use the visualization and work with it in the future. Now, step 5 that we were fortunate enough to be able to do after my first lightning talk was we actually were able to get the app beta tested by Matthew Lee, who's someone else in the group, who after the first lightning talk was nice enough to reach out and said that he would help out. So we were able to send him the project right before filming our submission video, and we were able to get some great feedback from somebody who hadn't been developing the app, which had been previously the only people who had been able to test it. So we got some great user feedback that we were able to implement, some before filming our submission video, and furthermore, things that we knew to work on in the future. So with the project completely developed, here's what happened next after development. So after submitting our challenge video to NASA, where we had to film ourselves talking about the project and the project itself, we were fortunate enough to be one of the few selected teams out of all of the entries to advance to the next level of the project, which was an interview with a team from NASA. So this team included people such as NASA scientists themselves who are working on current missions, people that are working on the Artemis project itself, and furthermore, those that just work with the app development project solely on its own. So in order to do this, we answered some pre-submitted questions that they sent us in a Word document, and furthermore, they were able to elaborate off of this with us in our interview with them. So that was a really cool experience to get to talk with all of them. So now that the interview is done, now we wait and we'll find out if we're one of the few selected winning teams on January 8th via a live stream done by NASA on YouTube. So if we're one of the few selected teams to win, that means that we could have the opportunity to work with NASA on this visualization in the future and help them with this mission to the lunar South Pole going into 2024 in the next few years. But furthermore, they also stated that because it's being done virtually, we'd have the opportunity to present our project worldwide via a live stream if we're one of the selected teams to win. So, with all that in mind, I just wanted to give a great big thank you to not only this group, but the entire Techlahoma Foundation for giving me the opportunity to share this project and get help and feedback. It means a lot to me and to the team, as it led to great experiences and us getting some great feedback that we may not have otherwise gotten. If y'all have any questions or want to contact me in any way, you can just reach out to me on Slack on the C# page, just my name, Lauren Smith. Also, if you want to get in contact with any of my classmates that worked on this project with me, feel free to. We're all certified in our software fundamentals certification, and we'll be looking for jobs in that field in the near future. So we'd love to have any sort of opportunities or answer any questions that y'all may have for us. Thank you so much.
That is awesome. We've actually gotten some great questions in Twitch, if you wouldn't mind answering them. One was, where did you gain your initial knowledge that you used on this project?
So the main way we gained our knowledge is, for one, we were fortunate enough for the project that NASA does a great job of offering us some formulas in the guidebook for us to use in order to make our calculations, offering us some textures and things of that nature. But furthermore, if we didn't already know it, most of our knowledge just came from the magic of trial and error and Google, to be honest. There's a lot of forms for Unity out there, luckily. So if we didn't know, it was a lot of trying different strategies, seeing if it worked, and looking to the Unity forums and different videos to see how we could take our approach.
Awesome. Did you use source control for the code? And if so, is there a public link where we can go look at it?
It's not uploaded as of right now, but I'm sure that we could ask about getting it uploaded in the future.
Yeah, that'd be great. If you have that, post it in our Slack channel. I was also wondering if you would share a link to the live stream on the 8th and post that in our Slack channel so we can watch it and see if you're
Yeah,
selected.
of course.
That's awesome. I really appreciate you giving the talk before and this one now. And like you said, getting help from Matthew Lee. That was awesome. Um, any other questions for Lauren? I'll give it just a couple more seconds and then we'll switch to Rebecca. Yeah, someone said, great job. Great job, Lauren and team. Keep up the great work. Still curious about the source control that you used amongst your team. Like, did you use Git? Did you use something like
Oh,
that?
right. So communication was kind of funny, especially given the pandemic circumstances. So what we ended up using is we made a Discord server for all of us, which made it really easy because that way we could separate it into different channels. So we had a code channel, graphic design, community outreach, etc. Um, Outside of that, we used Unity Teams in order to collaborate. So that way multiple people could access the project and work on it at one time. And also on that Discord channel, we were able to use what's called a Unity Discord bot, which basically when anybody made changes to any of the assets on the project, it would upload with a note. So this made it nice because if anything were to happen, we could just always look back at the Discord channel and go, it was this update. We can go back to that before it was changed and broken.
Yeah,
So
awesome.
it was a good way to keep everybody up to date and make sure that most of us had access to the project.
Cool. Yeah, this was an awesome project. It sounds like you learned a lot. If anybody wants to ask more questions, feel free to do that in the OKC Sharp Slack channel, which, by the way, is back up. Um, there's another question. Could you name some algorithms that you used? And not to put you on the spot too much. So if you want to answer that in Slack later, you can do that. That might be a little more specific than you want to answer right now.
Off the top of my head, I know that like I stated in the presentation, we used like the a path finding package and took those paths and made it to where it followed and traced it. So that was something that we used. Furthermore, we compared distances between things in order for those communication link checkpoints. I can get a more detailed answer in Slack with the student that worked on those specific processes, but that's what I know off the top of my head right now.
That's great. Someone asked for your feedback on your experience at the Moore Norman Technology Center, which I don't know how much you want to get into detail on that either. Hopefully, it was great feedback that you have on them.
Yeah, so Moore Norman is great. I'm a second year student there because I'm in a 2 year long term program. But it's great. The programming and software development program is really awesome. We go pretty in depth about a lot of things. So when I graduate the program, I'll have experience in Java, C Sharp, Python, and Visual Basic. And we're looking at changing out Visual Basic for C in the near future, along with some mobile app development experience. But what I think is really cool about More Norman is not only do you learn like how to collaborate and work together with your classmates, but they also teach you things like interview skills and things of that nature. And furthermore, as you all have seen, when you get into like second year, as long as you're on top of your curriculum, you get to participate in these cool projects, which not only is like really cool, but gives you really good industry experience and things of that nature.